Hey, welcome back 8th grade to another lesson with Mrs. Cartwright. Right now we're going to talk about multi-step equations. So we had just done a lesson on two-step equations. Now, we're going to talk about what do we do if we're not completely simplified down to just those two steps. So there are two questions that I'm going to write up at the top before we get started on this. Those two questions are, number one, ask yourself, do I need to distribute? If the answer is yes, then you're going to go ahead and distribute and then move to the next question. If the answer is no, then you just move to the next question. There's technically going to be 3 of these questions. We'll get to the third one in the next video or in the next lesson. But question 2 is, are there same side like terms? Because there will come a time when we'll have the variable on both sides of the equal sign. You may go, whoo, what do I do with that? Well, that's a topic for another video. But what I like to do is, when I start getting multiple things going on and it's not just a simple two-step equation, I start to draw a line through my equal sign, because that's going to help me know whether my variables are on the same side or on different sides. So in this case, do I need to distribute? The answer is no. There's no parentheses, right? That would indicate the distributive property. But for question number 2, are there same side like terms? And the answer to that is yes. I have 5m and a positive 2m. Now notice I'm taking the sign with it. This 23 is a negative 23. So I'm just going to combine. So if I'm writing my proof out as I go, right, that this is the given. And then the 5 is just going to come down. And I'm going to do 5m plus 2m, which is 7m. And so what I did right there is combine like terms. Now, we call them like terms when they're on the same side. If we're having to move them from side to side, that would be a subtraction property of equality or an addition property of equality, and we'll get to that later. But there is a difference between same side like terms and terms that are similar, but we're having to move them across the equal sign. From here, now I have a two-step equation, so I'm going to treat it as such. So since this is a negative 23 and I want to zero it out, I'm going to use APOE, right, addition property of equality, and I'm going to add 23 to both sides. And so that's going to give me 28 equals 7m. And then from there, I'm going to use my division property of equality to divide both sides by 7 to get m by itself. And I get 28 divided by 7 is 4. You use the symmetric property, and now we can say that m equals 4. All right. If I'm not sure if that is correct, then I go off to the side and I say, okay, well, 5 is supposed to equal 5 times 4 minus 23 plus 2 times 4. And so I would end up with 20 minus 23 plus 8. And so then 5 would be a negative 3 plus 8. So 5 equals 5. And it works. And so that means m equals 4. Again, if you're unsure, plug it in and see if it works. All right, next slide. So we ask ourselves the first question. Do I need to distribute? And the answer is yes. I have this multiplication to a parentheses with a variable inside that parentheses. So I can't simplify what's inside my parentheses first. And so, starting with our given, then we're going to distribute into my parentheses. And only into the parentheses. So negative 8 times 2 is a negative 16x. Plus negative 8 times a negative 1. And you are going to save yourself so much time if you treat that as a negative 1 and not just negative 8 times 1, and then you would have negative 16x minus negative 8, right? So I'm going to treat this as negative 8 times a negative 1, which is a positive 8. I've already done my sign change. I don't have to do it later. All right, so from there, that was us distributing. All right, from here, again, two-step equation. I would ask myself, do I have same-side-like terms? In this case, we can look at it and see that it's already a two-step equation, so we keep moving. And so I'm going to subtract 8 from both sides. And so now I have a negative 16x equals, and then 36 minus 8 is 28. And so that was our subtraction property of equality. That's how we got that answer. And then from here, we're going to use the division property of equality. And I'm going to do my inverse operation and divide both sides by negative 16. Don't drop that negative. Okay, it is important. And so that we're getting a x is, now 16 does not go into 28 evenly. Rarely does it ask for a decimal, so make sure you're reading the blue words on Math Excel. So what we're going to do is we're going to simplify. I know that 4 will divide into both of these. And so positive negative means our answer is negative. 28 divided by 4 is 7. 16 divided by 4 is 4. And so we end up with a negative 7/4. And again, if you are unsure, then plug it back in. Right? Negative 8 times 2 times a negative 7/4 minus 1 should give us a 36. And so I'd have negative 8, and then the 2 would simplify the 4, right? Because this would be like 2 over 1. And so now we have a negative 7/2. I'm going to change this 1 into 2/2, because 2 over 2 is 1. But that's going to make this next step easier. Negative 8 times, and then negative 7 minus 2 is a negative 7 minus 2 would be the same as plus a negative 2. So a negative 9 over 2. And that's supposed to be 36. And I think Mrs. Cartwright made a mistake somewhere. Nope. So then when we multiply this, see, Mrs. Cartwright started to doubt herself, and she shouldn't have. When we multiply this, the 2 will simplify with the 8, making this 1, and then making this 4, because 8 divided by 2 is 4, and negative becomes a positive. 4 times 9 is 36. So we get 36 equals 36. And so that means that this is the correct answer. All right. So again, what I'm getting at is, instead of freaking out because it's a fraction, go plug it back in. And if you need help plugging it back in, that's one thing. But don't think that the answer is wrong just because you came up with a fraction. Okay. In the next video, we will talk about what if they give you a whole bunch of fractions in your problems or decimals, and how could we get rid of them so that it's easier to work with? So I'll see you there.